Okay, let's go over homework 3.3, number 8. Alright, so we are looking for local extrema, so we need to find the critical numbers. Alright, so let's try that. So first derivative, so f prime of x is going to be equal to, alright, so we can probably use a quotient rule. So square the bottom, so you have quantity x squared minus 9 squared, right? Derivative of the top is 0, right? So I'm not going to write down. Multiply by anything is 0. And minus top 45, right? Times the derivative of the bottom, which is 2x, right? So you can simplify it to negative 90 x, negative 90x over quantity x squared minus 9 squared. Right? Right, then so we have a critical number, so we can just set that equal to 0. Right? Right, then we'll see that we can just set the numerator equal to 0, so it's negative 90 x equal to 0. Then obviously, you can divide through by negative 90 to get x equals 0. Right, so that will be our critical number. Right. All right, then we'll probably do a second derivative test. So you have only one critical number, and we still need to find points of inflection. So we need a second derivative. So let's take another derivative. So f double prime is going to be, right, another quotient rule, right? So I'm going to put the negative 90. So this is just a constant multiple. So I'll put it in front. So negative 90. Right, then use the quotient rule. Right, so square the bottom. So x squared minus 9. And it's already squared, so it's going to be the fourth power. Right, then derivative of x is 1 times the bottom, which is quantity x squared minus 9 squared, right? Then minus top is x, and the derivative of the bottom is 2 in front. Keep the same quantity x squared minus 9. Then multiply by derivative inside, so it's 2x. Right. Then what we need to do is we try to factor out the common factor, but let's see, you can see that there's x squared minus 9, there are actually two of them right here. And then the second term has x squared minus 9 as well. Right, so I'm going to pull that out. Right, so you have a negative 90 is there. Then you have x squared minus 9 is there. Right, so once you pull that out from the first term, you actually have another x squared minus 9. So you have x squared minus 9. Right, then you have minus, let's say 2x times another 2x, so minus 4x squared. So minus 4x squared. Right, then divided by quantity x squared minus 9 to the fourth power. Right? Then we can cancel out the common factor. You have a quantity x squared minus 9 on top. So we can cancel one of them, so it turns into cubed. Right? Then you can see that here, this guy, if you combine them together, you're going to get the negative 9, actually negative 3 x squared minus 9, right? So we can actually pull out negative 3 from there. So you have, right, negative, negative, it's going to be positive, and the 3 factor out. 3 times 90 is 270, so 270, right? Then what's left is x squared plus 3, right? Because 3 is factored out from there. Then on the bottom, you still have quantity x squared minus 9 to the third power. Right. So that's the second derivative. Alright, so we're looking for local max and a local min. There's only one critical number, which was x equals 0. Right? So let's check, let's do the second derivative test there. So f double prime of 0, right, is equal to, alright, so if you plug in 0 here, actually we don't need to find the value, we just need the sign. So 0 here, 0 squared plus 3 is positive, so that's positive. And 0 squared minus 9 is negative 9, cubed is negative. So positive on top, negative on the bottom, so the whole thing is negative. So it's negative, right? So by second derivative test, so we know that, so I'm doing a second derivative test. We know that f of 0, right? So remember, second derivative is negative, which means that we have a concave down shape, and we're looking at the critical number here, so it's going to be a local max, right? So local maximum occurs at the 0 comma, right? I have to find a corresponding y value by plugging in 0 into the original function, right? So plug in 0, so it's going to be 45 over 0 squared minus 9, right? So it's going to be, let's see, it's going to be negative. 45 divided by 9 is 5. So 0 comma negative 5, right? And since that's the only critical number, so there's no relative minimum. So relative minimum would be does not exist. Right? Then find the points of inflection. All right, so it's going to be, let's see, we have to look at the sign of around, oh, actually, let's see, is there any, if you set the second derivative equal to 0, actually, you can see that this is never 0. You can see that the top is always positive because you have x squared, then you're adding a positive number and a multiply by a positive number. So this guy is actually never 0, right? So inflection point actually does not exist. So does not exist. All right, then we can sketch the graph using, let's use Geogebra. All right, so let's open up Geogebra. Okay, so let's type in the function, and the function was 45, so it's going to be y equals 45 over x squared minus 9. Right? Then hit enter. Alright, so you can see that this is the graph. Maybe I'll rescale it a little bit so that maybe we can see it a little bit better. Right, so that's the graph, and you can see that there's vertical asymptote at x equals -3, and there's a vertical asymptote equals x equals +3. Right. But you can see that there's only one critical number, and here's the local maximum there. There's no local minimum, and you can see that there's no point of inflection. All right, that's it. I hope that this was clear.